In the last two videos, we saw how LCM and HCF, that is, lowest common multiple and highest common factor, are used in real life. In case you missed it, or if you are curious to learn, then the link to those videos is given in the description box. Do check it out. In today's video, let us recall the terms we will need for LCM and HCF. Terms like multiples, factors, prime numbers and composite numbers will be recalled. Not just that, concepts which are needed to calculate LCM and HCF like divisibility rules and prime factorization method will also be revised. Now, how do you find multiples of a number? When a number is multiplied with any other number, we get multiples of that number. For example, multiples of 7 can be obtained by multiplying 7 by 1, 2, 3, 4 or any other number other than 0. So we get multiples of 7 as 7, 14, 21, 28 and so on. One thing to note is that every number is a multiple of itself and every multiple of a number is greater than or equal to that number. Also, we cannot say that a number can have only this or that many number of multiples. No, a number can have endless number of multiples. It can have infinite number of multiples too. A number that can divide a number perfectly is called a factor of that number. That is, the divisor of a number will give a remainder 0 when divided and that number is called a factor. For example, consider the number 4. When 1 divides 4, the remainder is 0. So, 1 is a factor of 4. Likewise, when 4 is divided by 2, remainder is 0. So, 2 is also a factor. But when 4 is divided by 3, remainder is not 0. Instead, remainder is 1. So, 3 is not a factor of 4. When 4 is divided by 4, the remainder is 0. So, from this we see that 1, 2 and 4 are factors of 4. Likewise, factors of 1 is 1. Factors of 2 are 1 and 2. Factors of 3 are 1 and 3. Factors of 5 are 1 and 5. Factors of 6 are 1, 2, 3 and 6. So, from this you can say that a number can have more than one factors and also the number of factors is finite. Also, you would have noticed that 1 is a factor of every number and for a number, one of the factor is the number itself. Factors of a number will be less than or equal to that number. Number which has only two distinct factors will be called a prime number. For example, here 2, 3 and 5 are prime numbers. Also, a prime number has only two factors, right? One factor will be the number 1 and the other factor will be the number itself. The number which has more than two factors are called composite numbers. For example, here numbers 4 and 6 are composite numbers. Now tell me, is 1 a prime or a composite number? Since 1 doesn't have two distinct factors, it cannot be a prime number. And 1 does not have more than two factors, so it is not a composite number either. So how should we call 1 then? We say 1 is neither prime nor composite number. The first few prime numbers are 2, 3, 5, 7, 11, 13 and so on. We can see that of all the prime numbers, the only even prime is 2. The others are all odd numbers. But that doesn't mean that every odd number is prime. No, the number 9 is odd, but we cannot call it prime because the factors of 9 are 1, 3 and 9. Also, every composite number can be written as a product of prime numbers. For example, 4 can be written as 2 times 2 and 6 can be written as 2 times 3. A number written as a product of two or more numbers is called factorization. Furthermore, if a number is written as a product of only prime numbers, then that will be called prime factorization. Before we learn how to do prime factorization for a composite number, let us first revise the divisibility rules of 2, 3, 5 and 11. Multiples of 2 are divisible by 2. For example, when 18 is divided by 2, we get quotient as 9 and remainder as 0. Some of the multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 and so on. From this pattern, we can see that any number with 0, 2, 4, 6 or 8 in its units place is divisible by 2. Or even better, we can say that every even number is divisible by 2. Next, divisibility rule for 3. When you observe the multiples of 3, there doesn't seem to be any common pattern here. But you can note that when the sum of the digits is divisible by 3, then that number is a multiple of 3. For example, consider 18. Sum of the digits of 18 is 1 plus 8, which is equal to 9. 9 is divisible by 3 and so 18 is also divisible by 3. Now tell me, is 231 divisible by 3? By the divisibility rule, sum of the digits, that is 2 plus 3 plus 1 is equal to 6. 6 is a multiple of 3, right? So 231 must be divisible by 3. Next, divisibility rule for 5. When multiples of 5 are observed, we see a pattern here. When one's digit is either 0 or 5, the number is divisible by 5. For example, the number 2572 is divisible by 5? No, because there is no 0 or 5 in the ones place. Finally, divisibility rule for 11. There is no straightforward pattern here. First, find the sum of digits in the odd places from right to left. Then, find the sum of digits of even places from right to left. Now, calculate the difference between these sums. If the answer is either 0 or is a multiple of 11, then the given number is divisible by 11. That's all. For example, consider the number 308. Sum of the odd places from right to left is 8 plus 3, which is equal to 11. Sum of even place is just 0. Difference between 11 and 0 is 11, which is divisible by 11. So the given number 308 is also divisible by 11. Not just these, there is divisibility rules for the composite numbers like 4, 6, 8, 9 and 10 also. But since we do not need them for prime factorization method, I don't want to recall them. There is divisibility rule for the prime number 7 too. But instead of that, we can actually divide the number by 7 and check for the remainder to be 0. That is easier. So come on now, let us see how to do prime factorization. Prime factorization can be done by two methods. Number 1, factor tree method. Number 2, division method. In factor tree method, we first write the given number as a product of two numbers. If those two numbers are prime, then we would stop there. If not, we further write each number as a product of two numbers. We continue to do so until all the factors are prime. Once we get all prime numbers, we stop and write the given number as a product of these prime factors. That's all. When you rotate this upside down, this looks like a tree, and so that's why this method is called factor tree method. The given number can be written as a product of any of its factors. No problem, because in the end we will always get the same answer. So any given number can be written as a product of prime factors in just one way. There cannot be more ways except the order of the factors will change. That's all. For example, let us find prime product of 36. 36 can be written as a product of 3 and 12. Since 3 is prime here, we stop there and concentrate on 12 now. 12 is a composite number and so we write it as a product of 4 and 3. Here too we get 3 which is prime, so we leave it there. We focus on 4. Writing 4 as a product of 2 and 2, we will get our factor tree. We stop here as all the ends are prime. Now we can write 36 as 3 times 2 times 2 times 2. Usually the product is written in ascending order and so we rewrite it as 2 times 2 times 3 times 3. Next is division method. This is where we use the divisibility rules. In this method, the given number will be divided in an order by only prime numbers until we get a remainder as 1. Starting from 2, 3, 5 and so on, we divide the given number by prime numbers. For example, let us find the prime factorization of the number 600. Can this number be divided by the smallest prime number, that is 2? Yes, units digit is 0, right? So this number is divisible by 2. When you divide by 2, we get quotient as 300. We need to check whether this number is again divisible by 2. We keep doing this until the number we get is not divisible by 2. On dividing 300 by 2, we get 150. As one's place has 0 again, we further divide by 2, and on dividing, we get quotient as 75. But 75 is not divisible by 2 as the ones digit has 5 in it. So let us check whether 75 can be divided by the next prime factor, that is 3. Do you remember the divisibility rule for 3? Yes, you need to find the sum of digits and check whether the sum is a multiple of 3 or not. So 7 plus 5 is equal to 12, which is a multiple of 3, and so we conclude that 75 is divisible by 3. On dividing 75 by 3, we get 25 as quotient. 25 is not divisible by 3, so we check with the next prime number, that is 5. 25 is a multiple of 5, so we get quotient as 5. Further dividing 5 by 5, we get 1 as quotient. As we got 1, we stop here. Now, the given number 600 can be written as a product of these primes. That is 2 times 2 times 2 times 3 times 5 times 5. In exponential form, we can write it as 2 power 3 times 3 times 5 power 2. So, in this video, we recalled terms like multiples, factors, prime numbers and composite numbers. We even recalled divisibility rule and checked out how to prime factorize a given number. In the next video, we shall check out how to use these techniques to find LCM and HCF, that is, lowest common multiple and highest common factor of numbers. An assessment on this topic is given in the description box. Do check out the link and complete the homework. If you have liked this video, hit the like button. If you have found this video easy to understand and useful, share it with your family and friends. Do record your views in the comment section as this will encourage us to create more useful videos. Do not forget to subscribe to Fun Maths Academy channel to get constant updates on new videos we upload. Thank you.